Hi guys, Mrs. Waymeyer here today. We're going to talk about the 4 different ways to multiply whole numbers. These strategies will work with decimal numbers, but we're going to focus on whole numbers today. I'm going to use this same problem throughout in all 4 strategies, and of course, whichever one makes most sense to you and your brain is the one that I want you to choose. A lot of students choose the traditional method because that's kind of what their parents and teachers have shown them, but none of these other strategies are wrong. Actually, these other 3 strategies incorporate a lot of number sense, and so I encourage you to maybe at least try those. But of course, if traditional method is the one that you choose that works the best for you and you're able to get the right answer, then use that. So we're going to use 68 times 49 throughout all 4 of these problems today. So the first thing that I want to do, I'm going to write this just a little bit bigger, is line up my digits. And the first thing that I'm going to do is multiply out my 9. So I'm taking this apart digit by digit. I'm not really taking into consideration their place values right now. So 9 times 8 is 72. So I'm going to mark down my 2 because it's in the ones and carry my 7 because it's in the tens. I'm ignoring my 4 right now because I'm just working with my 9s in the ones place. So then the next thing that I'm going to do is take 9 times 6, which is 54. 54 plus 7 gets me 61. So here's where some people change kind of a little bit differently in traditional method. I call it the tic-tac-toe method, where I cross out my 9 and I put an O here, so tic-tac-toe. Some people call it the turtle method, where you're crossing that out. But the big thing you need to remember is you're done multiplying out your 9. You're now moving to your 4 and multiplying that digit out. You do also need to remember to put your place value or placeholder here. If you don't, then your digits are going to be in the wrong spot when you go to add. So 4 times 8 is 32. 4 times 6 is 24. And then we also need to remember to add in this 3 that we carried. Makes it 27. My digits are lined up, and so then I'm just going to add these 2 numbers together to get my final answer. 7 plus 6 is 13, carry my 1. So my final answer to this problem is 3,332. Let's say that I am not a fan of traditional method, looking for something different. I'm going to use what's called lattice. Now, lattice is a little bit tricky in that you have to draw the boxes and you also have to draw your diagonals here. So the way that the diagonals are drawn, they're cut through these boxes. This is a 2 by 2 problem, so that's why we have 2 by 2. If you were to have a 3-digit number on top and a 2-digit number down below, then you would still need to add an extra row or column based on that problem. So 68 times 49, I'm going to break it apart by its digits. So I'm going to put a 6, and then an 8, and then a 4, and then a 9. And the reason that I have these diagonals drawn in this box here is because I'm going to take 8 times 4, and I get 32. I'm going to put 3 on top and 2 on bottom because 3 is in the tens place and 2 is in the ones place. Then we're kind of seeing where those boxes connect and intersect. So 8 times 9 gets us 72. Again, I'm breaking it apart by tens and ones, kind of ignoring my diagonals for a second. Then 9 and 6 intersect in this box, which we know is 54. And then 6 and 4 intersect in this box, giving us 24. Now the diagonals are important because they already have them lined up by their place value, whereas over here when we were adding, we had to make sure that they were lined up correctly. So when I add across those diagonals, I get a 2. 7 plus 4 is 11. 2 more gets me 13. Because I have 13 here, I'm going to take and move that over to the next place value and carry it to the next diagonal. Make sure that you're not adding the numbers on the outside. Those were kind of our beginning numbers, so we're not adding those into the totals. 9 plus 1 more is 10. 13. Again, I need to carry a 1 to make this a 3. So when I line those or write those all out horizontally, again, I get 3,332. I like lattice. It breaks it apart into your mental facts really quickly and really easily. The problem that I see a lot of students struggle with this one is their diagonals and being able to draw those in. So just be very careful with those, and especially when you start getting into bigger digits and bigger numbers. Box and cluster looks very similar to lattice except without our diagonals. And we're going to break this apart by place value. This one broke it apart by digit. So when I put my numbers on the top of the boxes, it's going to be 60 and 8 because 68 makes 68 and 49. Really doesn't matter whether you put it on the left or the right. I just like to put it on the left if I can. Of course, you could put it on the right side and it would still work. So same principle, same idea as what we're doing up here. We're going to find where those numbers intersect with each other and multiply them. But this time, instead of taking 4 times 6, I'm taking 40 times 60. So I know 4 times 6 is 24, and then I also know I need to add 2 zeros. So that makes it 2,400. 40 times 8, 4 times 8 is 32, with a 0 added to get 320. 60 times 9 is 540, and 9 times 8 is 72. So then with those numbers, to get my final answer, I need to add them up and get my sum, my total product here. This is where a lot of my students will mess up, making sure that you're lining up your place values so that you can get the right answer is where I see a lot of students make their common mistake. 2, 11, 13, carry my 1. 5 plus 4 plus 1 makes 10, 13. And again, we notice we still get the same answer no matter which strategy we're using. The last one is called partial products. You can set this up a number of different ways. I still like to set it up kind of like traditional style, but just know that I'm not really solving it this way. What I'm really solving is the place values. So again, very much like the box and cluster, just not drawn within a box. So if I do the first fact, I'm going to break it apart. So I'm going to break it up into 60 and here, let's do this. I'm going to break it apart into 9 times 8 first, and 9 times, last time it was a 6. This time I'm going to keep that place value and make it a 6D. So then we're done with the 9. We're going to take, this is not a 4. This is actually a 4D. So I'm going to take 40 times 8 and a 40 times 6D. So you'll notice a lot of those numbers look very similar to the ones in our box and cluster over here. So 72, 540, 320, 2,400. And again, you will notice we get the same product, same answer, same sum. This one is very much like box and cluster without the box. So I prefer these two methods because you're using your number sense, you're using your place values. However, there are people that are very quick with traditional and lattice. Again, to be an efficient mathematician, you need to choose something that works for you, that gets you the correct answer with no mistakes. So I'm going to encourage you on your paper, hopefully you are taking notes, put a star by the strategy that you're going to choose to use. And if you need a little bit more practice or a little bit more help, please watch the videos based on your specific strategy. So I'm going to make a video for traditional by itself, lattice by itself, box and cluster, and also a partial products. Feel free to ask questions if you need help. Hopefully this video gave you a good introduction to 4 different ways that you can multiply numbers.